All right, welcome back. This one is going to be on 11.2 systems of linear equations, which are matrices. This may or may not be your first exposure to matrices. I will be showing you how to do things in the calculator as well as doing it by hand. So for example, this goes with systems of equations. So if you had the system x plus 4y equals 14 and 3x minus 2y equals 0. We will go back to solving these like we were in 11.1 using matrices, but this right now we're just going to talk about how to write it as a matrix. So if I needed to write this as an augmented matrix, okay, you make these square brackets and you're going to write it without the x's and y's. So you just write the coefficients. So like our x's have a 1 and a 3. Our y's have a 4 coefficient and a negative 2. Then you draw this line to separate the x's and the y's, the variables, from the constants, which are 14 and 0. And then I finish it off with a bracket. That is the augmented matrix. You would call this a 2 by 3 matrix. You read down and then over to say like how big it is. Alright, so the notation in a matrix and just like how we identify stuff, this is kind of like a big generic example for that. That's the end of that one. Okay, so going down, you have your columns. So like we'll have column 1, and then you'll have column 2, so on and so forth, until you get to the end, which generically we'll just call it column N. So the things that go this way will be the columns. The things that go this way will be the rows. So like this will be row 1, row 2, blah, blah, blah. Generically, we'll call the last one row M. All right, so the first thing, the first number inside the matrix, this is a 1, 1. For column 1, row 1. Or row 1, column 1, sorry. This one is a part of row 1, but it's in column 2. So you do A sub 1, 2. So you get to the end where it's still part of row 1, but it's column N. And everything in the middle would be identified with counting. So now this one is part of row 2, so you do row 2, column 1. This one identified as row 2, column 2, all the way down to row 2, column N. And you would continue this way across and down until you got to, this is A, row M, column N, or sorry, column 1. This is A, row M, column 2, blah, blah, blah. So generically, this is A, row M, column N. Okay, and then this would be considered an M by N matrix. Alright, so getting to some examples from the book. Number 9, it just says to write the augmented matrix. where you are given a system of equations. We have 2x plus 3y minus 6 equals 0. And then you have 4x minus 6y plus 2 equals 0. So unlike the example I had done before, this one isn't quite ready to be put in an augmented matrix because your constants are not on the right hand side. So before I actually put it into an augmented matrix, I would need to rewrite it. This one, 2x plus 3y, and then the 6 moves to the right. This one, you have the 4x minus 6y, and then the 2 moves to the right and becomes negative. Alright, so then our answer, our actual augmented matrix, we have 2, 3, and then your constant 6 from the first one. The second equation, we have 4x, negative 6y, and negative 2, where everything is lining up. And that's the answer. That's all they're asking to do on that problem. Alright, so once you have things in an augmented matrix, you're going to be asked to do some row operations. And there's certain things you can do inside of a matrix, and they're considered legal, like things you can do and it doesn't affect the outcome of the matrix. And these are called row operations. Alright, so some things that are legal. First of all, you can interchange any two rows. Second, you can replace a row by a multiple of that row. So like you can multiply everything by the same number. And third, you can replace a row by the sum of that row and a non-zero multiple of another row. We'll practice this. Alright, so looking at number 19. Number 19, we have the matrix 1, negative 3, and then our constant is negative 2, and then the second row is 2, negative 5, 5. And then we're asked to do some row operations. So outside you have a capital R sub 2 equals negative 2 lowercase r sub 1 plus r sub 2. The capital is basically the new one, what it's going to be. The lowercase is the old row. So we're going to be multiplying negative 2 times our old row or original row 1, and then we're going to add it to row 2, and we're supposed to write the resulting matrix. So, first of all, this is a new row 2. That means row 1 is going to stay as it is. So it'll stay 1, negative 3, and -2. It's our row 2 that's going to change. And this is a lot. You just got to kind of do it in your head. So you're going to do -2 times row 1 and add it to row 2. So -2 times 1, that's -2, plus 2 is 0. -2 times -3 is 6, plus -5 is 1. -2 times -2 is 4, plus 5 is 9. And this is the resulting matrix. It is considered equivalent to the original one. We just did some row operations. And just so you know, we're going to be getting into reduced row echelon and row echelon form. And this one is in row echelon because you have a diagonal of 1s and there's a 1 here. So it actually means that y equals 9. But we're not quite there yet. That's a good example of it. All right, number 21 is going to be a 3 by 3 matrix. So the first one is 1, the first row is 1, -3, 4, and then it has a constant of 3. Our second row is 3, -5, and 6, has a constant of 6. And then this last row is -5, 3, 4, and then has a constant of 6. All right, and this one has two things for us to do. It says the new R2, excuse me, will be -3 times row 1 plus row 2. And then our new row 3 will be 5 times row 1 plus row 3. So we're going to be changing row 2 and row 3. That means that row 1 is going to stay the same. So row 1 will stay 1, -3, 4, and 3. Row 2, we do -3 times row 1, add it to row 2. Alright, so -3 times 1, that's -3, plus 3 would be 0. Next one, -3 times -3 is 9, and then plus 5 would be 4. -3 times 4 is -12, plus 6 will be -6. And then -3 times 3 is -9, plus 6 will give us a -3. Alright, now we're going to do the same, well, we have different things to do for row 3. Row 3 is 5 times row 1 and add it to row 3. Nothing to do with row 2. So 5 times 1, that's 5, plus -5 would be 0. 5 times -3 is -15, plus 3 would be -12. 5 times 4 is 20, plus 4 is 24. 5 times 3 is 15, plus 6 would be 21. So this is your new matrix, equivalent to the first one, but the rows changed. Okay, so that's practicing doing row operations. The book told us what to do. All right, so now let's talk about row echelon form. So row echelon form means you're going to have a diagonal of zeros. This one that we just did is going in the direction of row echelon form, but it's not there yet. You have these two being zeros. You would need first of all, this whole diagonal should be 1s, and then underneath it would be zeros. So it's going in the direction because those two are 0, but it's not there yet. All right, so let's talk about row echelon form first. And if you have a graphing calculator, it can help you with this as well. All right, so first of all, the entry in row 1, column 1 is a 1, just like this one was. And then you only have zeros below it. Okay, so like I said, this one was starting to get there. It had the 1, and then it had 2 zeros below it. All right, the second thing you have to have in order for it to be in row echelon, the first non-zero entry in each row after the first row is a 1, and only zeros are below it. The 1 is to the right of the first non-zero entry. So the next thing we would need is for where this 4 is to be a 1. So this would be a 1, this would be a 1 with zeros below it. And then actually this one would be a 1 since we're on the diagonal. So the first non-zero entry in each row after the first row is a 1, and only zeros are below it. The 1 is to the right of the first non-zero entry, in any row above it. Well, this thing's just kind of hard to put into words. And then any rows with all zeros to the left of the vertical is at the bottom. Okay, so basically your row echelon form, you have a 1 here, zeros below it. You can have a number to the right of the 1, but below that number should be another 1 and a 0 below it. The last column, you can have the last column before the vertical, you can have numbers above, and then you should have a 1. And then there can be numbers over here. Numbers other than 1 or 0. Okay, that's row echelon form. There's another form which is actually more useful when it comes to solving equations, and that's reduced row echelon form. So what happens in this form, the big difference, is the numbers above the ones become 0. So it's row echelon form, but all the numbers above the ones are also reduced to zeros. But all the numbers above the ones are also reduced to zeros. That's ones. Okay, so it would look very similar. Just have ones on the diagonal, zeros below, and zeros above. And then to the right can be whatever. That part doesn't matter. All right, so if we look at number 27, it's going to give you the reduced row echelon form. Okay, so we're given 1, 0, and then 5 to the right of the vertical, and 0, 1, -1 to the right of the vertical. And it says the reduced row echelon form is given. Write the system of equations corresponding to the given matrix. Okay, so this one only has two unknowns. It has an x and a y that are unknown. So the first one is in place where the x would be. So that means x equals 5. And then this one means y equals -1. So that is actually the solution to that system of equations because it is in reduced row echelon form. We can do that. All right, let's look at number 29. It's a little different. I'm going to flip this page here. All right, so 29. We have 1, 0, 0, 0, 1, 0, 0, 0, 0, a little different, and then 1, 2, 3 to the right of the vertical. So this one is missing a 1 as far as reduced row echelon form goes. So that means you do have x equals 1. You do have y equals 2, but then here you have 0 equals 3, not z, because there's no 1 for the z. So that means this is an inconsistent. It doesn't, 0 does not equal 3. So it's inconsistent. So the answer would be no solution. Because you can't have that at the bottom and still have a solution. All right, let's look at number 39 where we're asked to solve the system of equations using matrices. And I'll do that without a calculator, and then I'll show you how to do it with a calculator. So you can do it either way. And chances are you're probably doing that. Well, you are. You'll be doing this test on my courses also, so you will be able to use a calculator. Now this one wouldn't be bad to do as a regular system because you could add them together pretty nicely. If you add them together, you'd have 2x. These would cancel, equals 12. So if 2x is 12, x is 6. But the idea is that we're teaching how to use matrices. So, all right, so first we need to put it into a matrix. So 1, 1, 8, and then 1, -1, 4. Okay, so we want reduced row echelon form. We have a 1 in our upper right, so we're good there. That's where you would start. We're good. But we need this to be a 0. So my new row 2 will be to do -1 times row 1, my old row 1, and add it to my old row 2. Alright, so first row is staying the same, 1, 1, and 8. So you have -1 times 1 plus 1 is 0. -1 plus -1 will be -2. And you gotta do the constants as well. -8 plus 4 is -4. Even here you can see -2y equals -4. But we're doing this using matrices, so what we can do, we want that to be -1. Really, we just take our new row 2 will be -1/2 of our old row 2, because that'll make that into a 1. So we're not using that first one for this one. Okay, 0 divided by -2 or times -1/2 is still 0. -2 divided by -2 is 1. -4 divided by -2 is 2. Alright, so we're good there. But now we just need this to be a 0. Okay, we're good. We know y is 2, actually. But we need to change row 1 now. So our row 1, this could be a -1, and we can add it to that. So -1 times our old row 2, add it to row 1. So -1 times 0, that's 0. Plus 1, that's why that's okay, because that stays 1. -1 times 1, -1 plus 1, there's our 0. -2 plus 8 is 6. And then row 2 stays the same. And there is the answer to the system of equations. You would have x equals 6 and y equals 2. Now, like I said, you can also do this on your calculator. So there's a whole menu for matrices. If you go shift and then matrix right here above x to the -1, this will tell you the matrices that you have in there. I actually don't have any. I just have the letters. I need to edit it to tell them what they are. So this is actually a 2 by 3 matrix. Down 2 over 3. Press enter and it kind of sets it up for me. So our matrix went 1, can't really see it. So 1, 1, 8, and I just press enter after each entry, and 1, -1, and 4. Now my matrix is there. The calculator automatically saves it for us. I could go back to my home screen, press matrix again, and now I can tell that there's a matrix in there. If I were to go to it and just highlight it and press enter, it'll show me the matrix that I have in there. But I want that to be in reduced row echelon form so I can check to see if my answer is correct. So I'm going to go back to matrix, math, reduced row echelon form. If you arrow down, or actually you can arrow up, row echelon form is A, but reduced row echelon form is B. So I'm going to click on that. Then I want that matrix, so I'm going to go into my matrix menu and just click on the one I want. So that's telling me to do reduced row echelon form for matrix A. There it is, and there it matches my answer. Way easier than going through all the steps. Alright. So the nice thing about video is you can go back and do that without, you can do that again if you need to. Alright, so like if we were doing number 49. Number 49 is a 3 by 3. You have x minus y equals 6. And you have 2x minus 3z equals 16, and 2y plus z equals 4. It is a 3 by 3. It's written kind of funny so that you can't directly see the holes, but there are holes there. So let me write the matrix out before I'm going to use my calculator to solve this one. So before I even do that, let's see, we've got 1, -1, 0, and then the constant on the right is 6. We have 2, the y actually is 0, -3, our constant is 16. Then you have 0x, 2y, 1z, and our constant is 4. We could do this one by hand. I'm just going to use the calculator on this one to see what we get, just to practice calculator. Okay, so reduced row echelon form, that's that RREF. So I need to go back. I'm going to put this matrix in for B. I actually need to go over to edit. Put it in for B. This one is a 3 by 4. Okay, and just put in the entries, 3, -1, 6. Okay, so I put in all my entries. Quit out, go back to the matrix menu, math, and I go up, reduce row echelon form, there at B, put in the matrix that I want, which is B, and there's the reduced row echelon form. As far as 3 by 3s, it takes a lot of steps to just swap rows and get to the answer you want, so it's way better to use your calculator. 0, 0, 1, and then 8, 2, 0. Having a 0 on the right hand side is actually okay, because now we just have x equals 8, y equals 2, and z equals 0, because you have the 1 there, so that makes it okay. So as a coordinate point, it's 8, 2, 0. And that's your answer. Matrices are kind of cool because you can just do that real quick. Alright, now I'm going to do one more, and that'll be the end of 11.2. This one just has a kind of different ending. Alright, number 57. It starts off very similar. We have 2x minus 2y plus 3z equals 6. 4x minus 3y plus 2z equals 0. And then negative 2x plus 3y minus 7z equals 1. So as a matrix, this one goes 2, -2, 3. Then you have the 6. You have 4, -3, 2, and 0, -2, 3, -7, and 1. Alright, so I want to see the reduced row echelon form for this one now. So I'm going to go under matrix. I'll call this one matrix C. So 3 by 4 again. Put in all my values. Okay, so there's our values. Go back to the home screen, then go back to matrix, math, reduce row echelon form, which is B. Tell it which matrix I want, which is matrix C at this point. All right, so this has the 0, 1 at the bottom. So a reduced row echelon form, 1, 0, negative 2.5. Ooh, I want to show you something with that too. And then 0, 1, negative 4, and 0, 0, 0, 0, and 1. Okay, so this is another case like we had earlier today, where you have 0 equaling 1. Because it's not 1z, it's just 0. So it's inconsistent and no solution. Okay, just so you know, with these matrices in the calculator, you can do that math and then number 1, change it to a fraction. You can do that with this as well, and it'll change like negative 2.5. I changed it to negative 5 over 2. So you can have it change your fractions inside a matrix as well. All right, that is the end of 11.2. Make sure you do your homework in my math lab, and I will see you again for 11.3. Have a great day.